Hello, I am Joseph George. In this video, we will discuss about the what's wrong with the mass energy equivalence principle proposed by Einstein and what is the actual mechanism of how nuclear energy is released. Einstein proposed the special theory of relativity, which proposed the idea that mass and energy are interchangeable. One can be converted into the other. According to this concept, the mass defect associated with in a nuclear reaction or any other process in nature are converted into pure form of energy. In a nuclear reaction, the missing mass is directly converted into energy. That is the fundamental idea behind the mass energy equivalence principle. However, according to my studies, I reached in a different conclusion. Now we'll look close into the fission reaction of uranium 235. When a uranium 235 undergoes a fission reaction, it creates a barium nucleus, krypton nucleus, and 2-3 neutrons. Here, the neutrons are traveling at a very high speed, almost at the same speed, but these 2 or 3 neutrons, they are traveling at a very high speed, but all of them are traveling at the same speed. Now, the biggest fragment, barium, travels slightly less than the speed of the krypton nucleus, because krypton is less massive than barium. So barium travels slower than krypton nucleus. So this, and also importantly, the heavier this daughter nuclei, the barium and the krypton, travels almost in opposite directions. So when you analyze this process, that the smaller particles, the neutrons, traveling at very high speed, and all of them are travel almost at the same speed, same kinetic energy, and the bigger fragment travels slightly less than the speed of the smaller second biggest big fragment, that is krypton. So when you assess or analyze this process through the lens of conservation of mass and conservation of energy, it leads to an interesting possibility. That is, there is a high probability of an internal explosion. So when you do math with considering these factors, it leads to a high probability of an explosion. It leads to the possibility that the missing mass explode. When you look through the lens of conservation of energy and conservation of momentum, the math leads to the high probability that the missing mass or mass defect undergoes in a rapid expansion. Now, when the explosion happens, it propels the reaction products at high speeds. So, when these neutrons, the high kinetic energy neutrons, collide with the surrounding matter, it results in the generation of heat. So we can mathematically verify that there is an explosion with mass effect. This is true for every other actions, nuclear reactions such as radioactivity. For example, uranium when a uranium 238 undergoes an alpha decay, the alpha particle travels almost at the 6% of the speed of light, and the product nucleus, the thorium 234, recoils in the just opposite direction. So this is like a gun shooting a bullet. The bullet, since it has lower mass, it travels at very high speed, and the heavy mass, that gun recoils in the just opposite direction. So when you see this phenomenon through the lens of conservation of mass, energy, and momentum, the same we will reach the same conclusion. So we can mathematically prove that there is a possibility of a rapid expansion or an explosive behavior of the missing mass. So I concluded that in a nuclear reaction, the missing mass explosively transformed into another form of matter. So this is my research about how a nuclear reaction releases energy. Thank you for watching.